Hello everyone, welcome back to Chemistry Chronicles where we make chemistry simple, engaging and fun. Our topic for today is naming of cycloalkanes. These are some rules we need to keep in mind while naming cycloalkanes. So our first rule says that we have to count the number of carbon atoms in the ring and the number of carbon atoms in the largest substituent chain to find our parent chain. Let's have a look at this example. Let's count the number of carbon in the chain. 1, 2, 3. Now let's count the number of carbons in the ring. 1, 2, 3, 4 and 5. That means we have to consider the ring as our parent chain as it has the maximum amount of carbons. Now let's have a look at the second rule. According to the second rule, we have to start numbering from the point that is closest to the substituent group or chain. As you can see, this carbon is attached to our substituent group and is the closest to it, so this will be our first carbon. And now we number the substituent group. This has 2 carbons, that means it's an ethyl group. First we will write the name of the branch, which is ethyl, and it is connected to carbon number 1, but we don't usually write carbon number 1 because by default it will always be carbon number 1 when there's only one group. And since there are 5 carbons in the ring, we will write cyclopentane. So the entire name will be ethyl cyclopentane. Ane comes from the name alkane and also because it has single bond. Pent because the ring has 5 carbons. Cyclo because the parent chain or the mother chain is ring shaped or cyclic. And ethyl because there is a substituent group containing 2 carbons in the first carbon of the ring. Now let's try to solve the next example together. We will follow the same rules in this case as well. But now we can see that there are 2 substituent groups attached to the carbons. So we will have to move to our third and fourth rule. Third rule basically says that we have to begin from the carbon or the substituent group that leads to the lowest set of locants. That means we have to start from a substituent group and then move in such a way that it leads us to the next closest substituent group. Here if we move this way, we can see that our two substituent groups are very close to each other. And now if we move in the opposite direction, we see that they are still closest to each other. So let's number them from here. 1, 2, 3, 4, 5. 5 carbons, and that means it is pentane. Now let's have a look at the substituent groups. There are 2 substituent groups and each contain 1 carbon. That means these cannot be our parent chain. Our parent chain is the ring. Since this parent chain contains 5 carbons in total, we will name it pentane. These carbons are attached in a cyclic manner, that's why we will add cyclo to our name. Moving to our substituent groups. There are 2 substituent groups, each containing 1 carbon, that means these are methyl groups. And there are 2 of them, so we will write 1,2 dimethyl it should be dimethyl. There is a mistake here, so there should be 1,2-dimethyl cyclopentane. 1 and 2 because these two methyl groups are in first and second carbon of the ring. Therefore, the name of the entire compound will be 1,2-dimethyl cyclopentane. 1,2-dimethyl comes from the substituent groups and cyclopentane is our parent chain. Let's try to solve some more questions. Have a look at this one. In the ring, we have 1, 2, 3, 3, 4 and 5 carbons. That means it's pentane. The number of carbons in the substituent group is 1, 2 and 3. You can count it this way or also you can count it the other way. So let's try 1, 2, 3. You can take this as a substituent group or that as a substituent group. It doesn't matter because all of them have the same number of carbons. As the ring has the maximum number of carbon atoms, we will consider that as our parent chain. Our parent chain has 5 carbon atoms. That means we will have the name pentane at the end. As this is in ring shaped, we have to add cyclo to the name pentane. Now let's see how many carbons the substituent group has. It has 2 carbons. That means it's an ethyl group. Now with this ethyl group, in the second carbon we can see there is another carbon attached. That means that group is a methyl group. In this case, the formula will be a little different. We have to write everything alphabetically. So first we will start from ethyl because that comes before methyl. Methyl group is in the second carbon of the ethyl substituent, so we will write 2-ethyl methyl. And since all of these are attached to carbon number 1 of the main ring, we will put all of this inside a bracket or parenthesis and we will write 1 near the parenthesis because this is the main carbon to which all the other carbons or substituent groups are attached. Quick recap, we get the name cyclopentane from the cyclic ring because it has 5 carbons and it is the longest chain. The part 1,2-ethyl methyl has been written here because methyl group is attached to the second carbon of ethyl substituent group and this ethyl group is again attached to the first carbon of the ring. Let's move to the next one. Let's count the number of carbon atoms in each group. This branch has 3 carbons. Now let's check the ring. This has 1, 2, 3, 4, 5 carbons. And the other branch has only 1 carbon. That means we have to consider the ring as the parent chain. And since this has 5 carbons and it is cyclic, so our last name will be cyclopentane. Now remember that we have to make sure that we number in such a way that the branches remain the closest to each other. If we number it this way, we get that 2 branches fall at 1 and 3rd carbon of the ring. And if we number in the opposite way, we see that they fall in the 1st and 4th carbon. That means the first orientation is the right one. Therefore, we will number it in this direction because in this way, the 2 substituent groups fall the closest to each other. After numbering the parent chain, let's number the substituent groups. First group has 2 carbons and we have numbered it 1 and 2. Second one has 1 carbon. So the first one is ethyl group and the second one is methyl group. Like I mentioned earlier, this entire circle is cyclic and has 5 carbons, so the name will be cyclopentane. Now we will arrange everything together to get the name of the compound. Don't forget to name them alphabetically. E comes before M. That means we have to mention ethyl group before methyl group. First we will write the name of the parent chain, which is cyclopentane. Ethyl group is attached to the first carbon of the ring, so we will write 1 ethyl. It's up to you whether you want to mention 1 or not. I have mentioned it, but it's okay if you don't. Now the methyl group is in the third carbon of the ring, so we will write 3 methyl. At the end we get the name 1 ethyl 3 methyl cyclopentane. 1 ethyl because the ethyl group containing 2 carbons is attached to the first carbon of the ring or the parent chain. Three methyl because the methyl group is attached to the third carbon of the ring or the parent chain. And lastly, cyclopentane because the parent chain itself is cyclic and contains 5 carbon atoms. Moving to the last problem of today. This looks a little confusing, but trust me, it's very easy. Okay, let's count the number of carbons. So here we have 1, 2. Here we have 1, 2, 3. And here we have 1. In the ring we have 1, 2, 3, 4, 5. 5 carbons. This is the highest number of carbons in the entire compound. That means the ring will get the priority and this will be our parent chain. Our parent chain or the ring contains 5 carbons and it is arranged in cyclic. So we will give the name cyclopentane. There are 3 branches attached to carbon 1, 2 and 3 of the ring. So we have to go in that direction so that we can get all the branches closest to each other. In the first carbon, there is an ethyl group attached because we can clearly see there are 2 carbons. And in the third carbon, there is a methyl group attached because there's only 1 carbon in the substituent group. And the second one, there are 1, 2, 3 carbons attached. That means it's a propyl group. Let's put the names alphabetically. E comes before P and M, which means we have to write ethyl first. Now you can either mention 1 or not mention it before ethyl. It won't make a difference. I'm mentioning it. I'm writing 1 ethyl here. After ethyl, we have to write the name of the substituent group that falls alphabetically after E, which is M. Therefore, we will write 3 methyl after ethyl because the methyl group is attached to the third carbon of the ring. Propyl is the only group that is left, so we will now write 2 propyl because propyl is attached to the second carbon of the ring. Okay, let's have a quick recap. 1 ethyl comes from the substituent group containing 2 carbons in the first carbon of the ring. We got 3 methyl from the branch attached to the third carbon of the ring. It contains 1 carbon, that is why it is a methyl group. And finally, we got 2 propyl from the branch that is attached to the second carbon of the ring and it contains 3 carbons. Since the parent chain or the ring contains 5 carbons, so we get the name cyclopentane. That was all. If you want to have a look at it again, you can go back and check it. It was very easy. You just have to remember the 4 rules that were mentioned in the first slide. I will see you in the next one. Till then, take care. Bye bye.